Today we are treating straight line equation. Welcome to my channel where we make it easy to understand science, technology, engineering, and mathematics. I am Dimeji. Let's begin. We start by location of points on a Cartesian graph. Location of points on Cartesian. Graph. How do we do that? This is how Cartesian graph looks like. With boxes, square boxes. So we take the vertical axis as the y-axis and the horizontal axis as the x-axis. We know we have small boxes, square boxes, and each one, depending on the ratio that you want to use, we take this 1, 2, 3, 4, 5. It goes. In the same way, we have all these boxes go up like this. So we have 1, 2, 3, 4. As it goes. Down we have -1, -2, -3, -4, -5. Down there like this. And on the left side, we have -1, -2, -3, -4. At least we are familiar with the graph. You know, all these ones will become boxes. So we are going to have squares. Squares. So this will be 1 centimeter by 1 centimeter and like that. Now to locate the points. This place we have it as 0. So it serves as 0 for y-axis and 0 for x-axis. That's the origin. Now we want to find point 3, 2. How do we start? Point 3 will be located on the x-axis and point 2 will be located on the y-axis. The front represents the horizontal axis and the one at the back represents the vertical axis. So we start like this. So this is 3, 2. Now if I want to locate 4, 3, 4, 3, I go like this. So this is my 4, this is my 3. That is 4, 3. Let's try to locate -5. No, 2 -5. 2 -5. You come to 2, that's the first, that's the x-axis. Then you come here, and that is 2, 5. 2 -5, rather. Now let's check -4 -3. -4 -3. So I'm going to have this -4 and -3. This is the points. And this is it. So -4 -3. So if I want to do -3 -4, I come like this. This is -3 and this is -4. So I have it like this. -3 -4. So with this, I believe you understand location of points on Cartesian graph. I want to talk about distance between 2 points. We have seen how the points are located. Distance between 2 points. Here, look at this first one. We have x1, y1. And the other one is x2, y2. You can see how they are located. Now I want to find the distance between x1, y1. Let's call x1, y1 A and B. x2, y2. Now the distance here is this. That's the distance. Let's call it D. The horizontal portion. The horizontal component, let me make it components, will be this. And the vertical component will be this. So we can easily get horizontal component. This place will be x2 minus x1. Vertical component will be y2 minus y1. Now, D, using Pythagoras theorem, d squared will be equal to x2 minus x1 squared plus y2 minus y1 squared. So D will be equal to square root of x2 minus x1 squared plus y2 minus y1 squared. That's the distance between 2 points. Now let's talk about the midpoint of a line given. We have a line AB with A being x1, y1 and B x2, y2. Now I want to find the point that is at the center, cutting the line into 2 equal parts, and that we call x, y. Now let's look at this line. If you cut it here, by our construction and knowledge of similar triangles, it means that this place, let's call this place C. AC is equal to CB. And in the same vein, it means that from this place to this place, let's call this D. BD is equal to DC. Let's call this place E. AE is equal to EC. So now we can see that this place is x1, this place is x2, and this place is x. In the same way, y1, y2, y. So it means that x minus x1 is equal to x2 minus x. Now I have 2x is equal to x2 plus x1. So x equals to x2 plus x1 over 2. In the same vein, y is equal to y2 plus y1 over 2. So the components of the midpoint of a line is the sum of the other side and dividing the sum by 2. Okay. Now we are talking about division of a line in a given ratio. That's a similar say divide this line in ratio mn. Just like what we did now. We are saying that x minus x1 over x2 minus x is equal to m over n. Okay, let me put it down. By knowledge of our construction and properties of triangle, we can see that this place 2, this place, let's call this place C, this place D. BD, the ratio of BD to DC will still be M, N, N. Here, call this place E. AE over AC is equal to M over N. Therefore, x minus x1 over x2 minus x is equal to n over n. Now, let me multiply both. Let me just change. This will be n into x minus x1 is equal to n into x2 minus x. So nx minus nx1 nx2 minus nx. Now I'm going to have it like this: n plus n into x will be equal to nx2 plus nx1. So therefore x will be equal to nx2 plus nx1 over n plus n. Normally this is referred to as internal division of a straight line. So you multiply the second point by n and the first point by n, you sum it over the sum of the ratios. That's the x. In the same vein, y2 will be equal to ny2 plus ny1 over m plus n. Now we are handling external division of a straight line. Let's say we have a line AB, and we are to divide it externally. The points where the external division will occur means it is going to be outside. That's why we call it external division. If it were to be internal division, the points will be in the between A and B. But now it will be beyond A or beyond B. Now we have point C, where we have AC to BC or CB in the ratio n to n. Now this place, let's call it x1 y1, x2 y2, and this place will be x y. On the x-axis, this place will be x1, this place will be x2, and this place will be x, the points of the division. Here now, we have similar triangles, and we can see that if this place is m, this place will be m minus n, and this place too, to the whole place will be the ratio m minus n to n. How do I mean? X minus x1, this whole place, over x2 minus x1, this place, will be equal to m over m minus n. Now I have x minus x1 to be equal to m x2 minus m x1 over m minus n. To make x the subject of the formula now, I have x to be equal to m x2 minus m x1 over m minus n plus x1, which will give me m x2 minus m x1 plus m x1 minus n x1 over m minus n. It's going to give me m x2 minus n x1 over m minus n. So the point is given as. Now talking about gradient of a straight line. We have a straight line like this. You can see that it's straight. And from our knowledge of trigonometry, we know that as it is going like this, the angle along like this, the ratio of this place to this place to constant throughout. So gradient of a straight line is constant all through. Gradient of a straight line is constant. Now, what do we mean by gradient? Gradient is when we are saying rate of change of vertical over divided by the rate of change of the horizontal. So if we have this place as y2, x2, y2, and this place as x1, y1, the gradient of this straight line will be equal to because change in y is y2 minus y1. So what is the corresponding change in x or the horizontal? Is x2 minus x1. So for a straight line, now let's talk about collinear points. We talk about collinear points when we have three or more points. When you have three or more points. And these points, when we say they are collinear, it means they are on the same line. And how do we know they are on the same line? We take 2 points, find gradients of these points. If the gradient between any of these 2 points are the same, it means they are collinear. Or if you try to find the area using any formula and the area gives you 0, it means they are collinear. Let's check with this. If we have points x1, y1, x2, y2, x3, y3. To find the gradient between 2 of these points, you can say between x3 and y1, you can say y3 minus y1 over y3 minus x1. If it gives you the same thing as y3 minus y2 over x3 minus x2, and gives you the same thing as y2 minus y1 over x2 minus x1, it means it is collinear. They are on the same line. But if any of these varies, if there is any difference, the 3 points are not collinear. We talk about collinear points from 3 points and above. Now we want to talk about angle of the slope. When we have a line like this, we can also talk about slope of the line. It's the same thing as tangent of the line. So we say this like gradient, yes. Gradient is equal to delta y over delta x. And if you look at this, by the time you look at it, you can see that tan theta corresponds to delta y over delta x, and theta will correspond to arctan delta y over delta x. So the angle of the slope is arctan the gradient of the line. Now, the gradient can be negative or positive. The line can go like this. The line can go like this. So this one is positive. This one is negative. That is, the gradient in this place is negative. Now, if you have it like this, y and x, they are both, as this one is coming down, this one is also changing downward as this one goes leftward. The gradient is also going to be positive. So let's remember our art. All positive, negative, for tangent I mean positive and negative here. So we can have it, we can have our tangent to be positive, we can have our tangent to be negative, and then we can also find the angle at every point in time. So the arctan of the angle it makes with the positive x-axis is the arctan of change in y over change in x. Now let's relate what we have talked about in gradients to what we are doing, straight line. Gradient of line joining two points. Let's say we have x1, y1 and we have x2, y2. So the gradient is change in y, change in x. So our gradient for this place will be y2 minus y1 over x2 minus x1. Now let's talk about angle between two lines. We have a line this making angle theta 1. Another line making angle theta 2. And we have established that theta, they are the arctan of the gradients. Now we want to find this angle here. Let's call this one beta. So this is that theta 2. Theta 2. By our knowledge of triangle, don't need to prove that, beta plus theta 1 is equal to theta 2. That is angle of the sum of two interior opposite angles to this external angle. Now beta will be equal to theta 2 minus theta 1. Now to find beta, that is just one way. You can use your tables. Say gradient of this one is m2, gradient of this one is m1. So theta 1 is equal to arctan m1, theta 2 arctan m2. So beta, that is the angle between the two lines, will be equal to arctan theta arctan m2 minus arctan m1. You can also use our knowledge of the sum of trigonometric ratios. We know that tan theta 2 minus theta 1 will be equal to tan theta 2 minus tan theta 1 over 1 plus tan theta 2 tan theta 1. So we can just find that by saying m1 m2 minus m1 over 1 minus plus m2 m1. So the arctan of this is going to give us our angle between the two intersecting lines. Parallel lines. We have parallel lines like this. So, from our knowledge, if these lines are parallel, Okay, let's think like this. And we have a line, straight line that cuts through. You can refer to it as intercept or whatever. So it shows that this angle here will be equal to this angle here, will be equal to this angle here, will be equal to this angle here. So what does that give? What does that show us? It shows that for parallel lines, the gradients are equal. So, and they won't come, they cannot intersect themselves, they cannot come in contact with themselves. So that is the major thing about parallel lines. The gradients are equal. Let's talk about perpendicular lines. It means that the two lines, the angle between them is 90 degrees. And from our knowledge of the sum of tangents, we can say that tan theta 2 minus theta 1 is equal to tan 90. Because, and we know that tan theta 2 minus theta 1 will be tan theta 2 minus tan theta 1 over 1 plus tan theta 2 tan theta 1. We know that tan theta 2 is gradient of line 2. Let's call this line 2. And this one line 1. So this is N2. Call this one M1. So gradient of line 2, that is M2, tan theta 1 is M1. So, and tan 90 is infinity. Now we know that infinity is equal to any number over 0. That is M2 minus M1 over 1 plus M2 M1. M2 minus M1 over 0. So 1 plus M2 M1 is equal to 0. So M2 M1 is equal to minus 1. So what this means is that when two lines are perpendicular, the product of their gradients is minus 1. The product of their gradients is minus 1. Of gradients of two intersecting lines is equal to minus 1. So M2 M1 is equal to minus 1. So M2 is also equal to minus 1 over M1, or M1 equals to minus 1 over M2. That is, gradient of one line is minus 1 times reciprocal of the other one, or vice versa. So this helps us to get the normal, perpendicular distance, and some other things concerning shapes of anything we are trying to find. So when we are talking about normal, now let's see, if we have an equation ax plus by plus c equal to 0, or any form. And we see that we are given that a parallel line passes through a point. That's a point P with coordinates h, g. What is the equation of the line through that point? From here, we know that parallel lines have equal gradients. So how do you go about that? Before we find the gradient of this one here, we say by equals minus ax minus c. So y equals to minus a over b x minus c over b. So our gradient is equal to minus a over b. Now we can see that the parallel line passes through hg. We can now say x minus h over y minus g over x minus h equals to minus a over b. So it's say by minus bg equals to minus ax plus ah. So I can now say by plus ax equals to ah plus bg. Rearranging, I have it like this: ax plus by is equal to ah plus bg. So to find a parallel line to another line passing through another point, all I just need to do is multiply the x components by a and y components by b to find my constants. The equation still remains almost the same. How do I mean? In this case, I have ax plus by is equal to minus c. So for the line that passes through this point now, all I need to do is to say ax plus by is equal to ah plus bg for the parallel line. So the only thing that differs now is the constants. Other parts of the equation remains the same. So you don't need to go through all this working. Just go there straight and you get your answer. Like now, if I have an equation, now let's look at perpendicular line. I have an equation ax plus by plus c equals 0. Let me find the gradient the same way. Ax plus by equals to minus ax minus c. So y equals to minus a over b x minus c over b. So the gradient in this place is minus a over b. Now for perpendicular line, as explained initially, we said that the perpendicular line, the gradient will be minus 1 over this gradient. So gradient of the line, perpendicular line, is going to be minus 1 over minus a over b. B is equal to b over a. From this, you can now say y minus g over x minus h is equal to b over a. Therefore, ay minus ag is equal to bx minus bh. So I have ay minus bx is equal to ag minus BH. So if you compare this equation with the initial equation, you will see that the coefficient of x and y changed and as minus. So if I want to find the perpendicular line without going through all this stress, all I just need to do is to say, okay, let me interchange the coefficient of x and y. So what do? I just make it here bx minus ay, or just to conform with what I have here, it's going to be the same thing at the end of the day. I just say b ay minus bx. Please note the change of sign. Note the change of sign. It's going to give me, I will now use this a to multiply the coefficient and the y components at the point which it passes through. So I will now say ag minus bh. That gives me the constant, and like that I've gotten my perpendicular line equation. So it makes it so easy to get your perpendicular line equation. It is perpendicular to the gradient. We'll get to that one too. Now let's look at distance of a line from origin. I have a line ax plus by plus c equals to 0. I'm trying to find P, the perpendicular distance from the origin. This is the angle. I don't know yet. But I can get the intercept of x and y. And this place is the origin. What happens? By the time I calculate this, I will see that if I make y 0, x is going to be minus c over b. If I make x 0, no, over a. If I make x 0, y-intercept is going to be c minus c over b. So I can get my distance from here and here. I can also get something at the same time. The length of the intercept is going to give me minus c over a squared plus minus c over b or squared. I can also get something now. P from here to here. Let's look at some other things. This place is alpha. This place will be 90 minus alpha. Here is 90 minus alpha. So since I have this one, here also is going to be alpha. At the same time, you can see I have 3 similar right angle triangles. P and this place. This will be the hypotenuse and P will be the adjacent. So P is equal to minus C over A cos alpha. Here P is the opposite. P equals to minus C over B sin alpha. And if you look at this place, cos alpha, because this is alpha, adjacent over hypotenuse. Cos alpha is equal to minus C over B divided by square root of C over A minus all squared plus minus c over b all squared. Now let me work this out. It's going to give me I'm going to have b squared, because this c is squared, I can bring this one out straight. B squared plus a squared all over a squared b squared, c over a squared c over ab square root b squared plus a squared. So this can be positive or negative. Here, and I have p is equal to, now let me finish this, cos alpha minus c over b times ab over a squared plus b squared. I can have it plus or minus. So this one cuts this. So p is equal to minus c over a times c cos alpha, yeah, c over b times ab minus c over a times c a over root of a squared plus b squared. Oh, here, see, this one we call this. So, that's not there. Now we are on area of plane sheets. We can easily find area of plane sheets irrespective of their orientation. Either triangle, quadrilateral, or any polygon. All we need to do is break it into standard shapes and add or subtract whatever. When we were young, we were given things like this. If we ask us, find area of shaded portion. The skill we needed then was to add, subtract, and do some other things. Look at this one too now. If you have to find the area of the shaded portion, what will you do? You find the area of the whole shape because you have a formula for that. You find the area of the triangle side and you subtract the area of the triangle from the area of the full sector. That's how you find that. So we are doing something similar in this area of plane shapes on our Cartesian coordinates. Now let's look at triangle. If you have a triangle like this, triangle will have three sides. Let's call it A, B, and C. X1, Y1, X2, Y2, X3, Y3. Now, what do? You just look at it. If X1 is not equal to X3, you return to knowledge of what you just did now. You break it into different shapes on how easy it will be for you. For me now, what I do is I draw this line parallel to the y-axis, and from B down parallel to y-axis, from C down parallel to y-axis. Now, if you cut the x-axis, let's say D, E, and F, I know this place to be x2 and this place to be x3. To find this, what will I do? I can easily see trapezium. So I find the area of trapezium DABE, area of trapezium EBCF, and I subtract area of trapezium DACF. That's all. So I just have it like this. Area of triangle ABC will be area of trapezium, let me say ADEB plus area of trapezium EBCF minus subtract area of trapezium DACF. You subtract this one from these other ones. I can also have the triangle in this shape. So this is my triangle. So I have A, B, C. In this instance, I am trying to find area of triangle ABC. Looking at this, the whole trapezium, I'm going to have ADFC, and then subtract trapezium ADEB plus trapezium BEFC from the whole trapezium DACF. Trapezium DACF minus sum of trapezium DABE plus trapezium EBCF. So just break it down like that. It is very easy in that pattern. But I said something the other time, please. I said if for C, like if you have it like this, it is very easy. If x1 is equal to x2 here, they are straight line. That's your vertical. And y1 is equal to y3 here. It means you can just subtract straight and get your area. So I have it like this: x1, y1, x3, y3, x2, y2. So if you look at this, this will be straight line. If x1 is equal to x2, and this one will be straight if y1 is equal to y2. So in this instance, the area of the triangle will just be x3 minus x1. That's the base. So x3 minus x1 into y2 minus y1. And sometimes you might not have it like this. It can just be like this. So it is very easy here too. If y1 is equal to y3, so y2, we just subtract it, it's going to be the same thing here. So in the same way, if we have it, just look at the shape very well. Now let's look at shape of quadrilateral. There is a formula using determinants. It's going to be, so area of triangle will just be x1, y1, x2, y2, x3, y3. That is the area of the triangle using determinants. So this one is also easy and straightforward if you know what determinant is. In this course, we still get to determinants and matrices later on. Just as I mentioned before, if the area at the end of the day is 0, it means the lines are collinear. Now, if you have a quadrilateral of this form, just as we handle that of triangle, the same way we are going to handle this one. You just cut it into shapes that you can easily handle. You can just say, oh, the whole area is this, and then you subtract this and this one and this part. Let's say A, B, C, D, E, F, G, H. Just looking at this merely, you can see we have trapezium here, we have triangle, let me see, you have trapezium here as well. So all you will do is find the area of the whole trapezium, H, yeah, A, B, C, D. So we have it like this. And then we can now subtract H, A, E, F and F, E, C, D from the area. So everything is just whatever way you feel like. You might even feel like, say, okay, if it's like rectangle, parallelogram or anything, you can cut it into two. Find the area of one portion of the triangle and say, yeah, 2 times this area of the triangle is the area of my parallelogram or quadrilateral or whatever shape, and then you find your answer. When we get to work examples, you will see what I'm talking about. But just have the mindset that your ability to cut into simple shapes will make it easy for you to get the area of the quadrilateral. Now, let's go to equation of straight line. That's what we have been trying to build on since. For you to get equation of a straight line, at least 2 things will be given. 1, we can be given the gradient of the line and 1 point on the line, a position of a point on the line. Another thing we can be given is position of 2 points. We can also be given gradients and intercepts on any axis, either on y-axis or x-axis. It is the same thing as giving us gradients and 1 position or points on the line. They are the same thing. Intercepts on the 2 axes is the same thing as giving us position of 2 points. Intercepts and gradient is the same thing as giving us gradients and 1 point. Now, we can be given perpendicular distance from the origin to the line, an angle of the perpendicular distance with the x-axis, or gradients of the perpendicular or of the line itself. You can be given the gradient of the line or the angle the line makes with the horizontal along that with the perpendicular distance from the origin. Now let's get to getting the equation of straight lines.